Hi and welcome to this video on Swift Absolute Basics. Now in this video we'll take a look at the variables, let constants, and we'll start with that. We'll also take a look at the Swift literals, and then we'll work our way towards the data types and operators and more. So starting with variables, I'll create a variable number integer, give it some value and print it. Running it, and there is another thing variable that is let constant, and I will print it. Now the difference between variable and let is variable is something which we can change again. Once I have assigned the value the very first time, I can change it again. I can reassign a value. It is mutable. So if I say number was to like this and I print it, this print function will give me the updated value. But when it comes to let, once we have assigned it a value the very first time, we cannot reassign it another value like this. It will show a compile time error, and hence this is something which is not mutable, and that is the only difference between these two. We can also give a double quote and enter a string here, and with the help of a comma we can now give this let constant here, and it will print its value along with the message value. Now let's move on to the next thing, that is Swift literals. Swift supports 4 types of literal: integer, floating point, string, and Boolean. Let's get started with this integer literal. Now what integer literal means that the first one is the decimal, second is binary, third is octal, and fourth is hexadecimal. These are all integer literals. Starting with the decimal is the value that uses base 10, and for example some random number, and I will print it here. Let's run it. So this is the number, the numbers uses base 10. The second one is binary integer literal, which is basically the binary values, the values that uses base 2. So I'll create an example here. So we have to use 0b as a prefix to mention these values. Let's say I have a binary value like this. I will print it. Let's run it, and it should give me a value 43. So although I've given a binary representation, it will turn it into a value and give me the actual value. Now the third is the octal integer. Now let's create a variable which will have an octal type value. Now we have to use a prefix o, 0o, and now we can give some octal value, and let's print this. That gives me 42. Although it's an octal value, it converts it into an integer and give me the value. Also, octal values are basically the values that uses base 8. The next one is the hexadecimal. So let's create variable for it. Now the prefix for hexadecimal would be 0x, and I can give the hexadecimal value here. Now hexadecimal values are the values that uses base 16. Let's try printing this. 255. And these are the 4 integer laterals. Now, when it comes to the real world use cases of these laterals, when it comes to decimal, these are widely used for everyday numeric values like count, price, IDs, things like that. When it comes to binary lateral, this is more of a used in low level programming. When it comes to the bit mask hardware registers, and when it comes to octal laterals, it is used in Unix like system when it comes to the permissions that we need to check for a user. And again, it's again a legacy level programming is where it is used. When it comes to the hexadecimal, this is something that we use when it comes to developing an application. So generally when you are working with some enterprise level application, the client usually has this color palette they use, and they have a specific color palette that they want to maintain in throughout the application. So hexadecimal values are the way we can accommodate the colors in our code. So let's take a look at the example of that. So starting with the binary integer lateral, I will share a piece of code here with you. And here, if you take a read permission, write permission, execution permission, if you take these 3 values, this is having OB as a prefix. That means it's a binary value. This is for read, write, and execute. In user permission, we are checking if the user has the permission for read or write, and that value goes here, and we check for the execute permission. If it is not, if it is there, then the user is good for the execute permission. Now let's take a look at the next one, that is the octal integer lateral. When it comes to Unix like systems, the file system permission for the files. Now if you take a look at this example, file permission has this value. Now the prefix is O, that is 0O, that represents its octal value, a value that uses base 8, and this is representing the file permission in Unix based system. And when we print this, radix is some logic that we are using. Now when it comes to the owner permission, group permission, and other permission, we are performing some operation including this right shift operator, right shift 6, and it creates a code for owner permission, and we can print it to take a look at how it looks. Let's run it. So in the last, you can see owner has 7, group is 5, and other is 5. So this is the code that we can use for permission level or permission code for different group, or owner has a different code for accessing particular file. The next is the hexadecimal that is we as a developer get to use. When it comes to the colors, so for example, the client has provided us the colors in an hexadecimal values. So I'll share an example. Now when it comes to the values, you can see 0x representing it's a hexadecimal value, the value that uses base 16. Now this is for red and this value is for green color and blue color. Now this values is something we can which could be different based on the client, and we can have a whole file representing all the colors that we are going to use in throughout the application in all the pages, and we can have a converter for that. We can provide this hex value, and we want to convert this hexadecimal value down to something that we can use in our code. So if we are using UI kit, we have UI color inside which we can provide the color, and it expects the value of type CG float. So what we do is we convert this hex using the CG float into the CG float type, and then we can pass it to our UI kit function and use it all the way in our application. And that is the one use case for it. And you must have seen enterprise level application code has these files where they have a lot of hexadecimal values representing colors that they will be using throughout. Now that we know the types of integer literals, we have floating point literals as well. So I will write here the types first. So we have total 4 types of Swift laterals integer. We have just seen what all integer laterals are there. I will mention it here. Now let's take a look at the floating point laterals. Starting with the first, that is the decimal. Now let's take a look at the example. This is the double type. We'll take a look at the data types later. Now double is the type that we use for storing floating point values, and we have a very let constant, that is item price, and we want to apply some tax rate on that of 7%. So we can represent that using the floating point decimal number, and we can have a total price, that is the price plus some tax percentage on this getting added, and we will just print it. Let's run this one. And we have this value with the percentage of tax added. Now let's take a look at the second type, the second literal of floating point, that is hexadecimal. And I'll mention the third one as well, that is the exponential literal. So this was the example for the first one, and for the second. Now hexadecimal is something that we use in low level programming, again when it comes to low level graphics programming, or we are interacting with the hardware APIs that uses base 16. Now I'll share the example. Now this is the value which has the prefix 0x, that means it's a hexadecimal value, and the whole value is representing the intensity of red color in graphics engine. And we can have a float type here for our let constant, and let's try running this one, and it gives us some sort of floating value. Although we have given it the hexadecimal, it will convert it down to the floating point value. Now let's take a look at the third one, that is the exponential. Now we have the we use e to represent exponent or power of 10. I will share an example for this. Now this is the value 1.243 E4. E means 10 to the power 4. Once we will print this value, we'll get to see this value. And now this floating lateral is used to represent when you're dealing with values which are very high or very low. By very low, I mean the 10 to the power minus 3 can also be uh, something that we can denote here. And let's print this. So we get these values. Now, this is something that we need when we are creating a scientific calculator, or when you're working on some finance related application and you need to do some high level calculations. This lateral is highly used there. Now let's move on to the next, that is the string lateral. Now string lateral are basically single line and multi-line. Let's get started with it. Now the string lateral is something, it's a sequence of character and we can represent it with a double quote like this, like this. And we can have some escaping characters in it. What are escaping characters? So if I were to give some double quote in here, I cannot do that. If I want to give change of line here, then I cannot do that. If I want to give a backslash, then that is also not possible. It will show a compile time error. So these are the few things that we cannot mention in a single line string. Now there is a way to mention that. We use the escaping sequence for that. That means if you want to represent a backslash, we have to give a backslash like this. And if I print this, I will get a backslash along with that. And just like that, if I have multiple words, and I want to represent them in different line, then I have to give this backslash nn to change the line. And let's print this. So I get hello, and in the next line I get welcome to the Apple other side. And just like that, we have something for introducing tab. So for T will be for tab. Let's run this. So we will have the spacing or a tab in between these words. Now if we want to introduce a single quote, for that I can give a backslash and single quote, and it will say hello, single quote, welcome to the Apple other side. So that was it. That was single line lateral, in which we cannot mention few of the characters, but we can use the escaping sequence, that is a backslash, and then you can mention that particular character to introduce that in our single line string lateral. The next is multi-line. We use triple inverted commas, and in the next line we can now mention our string like this, and it could be a multi-line as well. And it does not use any escaping sequence. For example, if you want to use a comma here, for change of line, you can just change the line. For inverted commas, we can just directly give it. You don't have to use escaping sequence here. Let's run it. Okay, so we have to give it a variable as well. And then let's print that. Run it. And if you'll see, it will print exactly the same. The characters we were not allowed to introduce in the single line literal without the backslash or the escape sequence, we can do it freely here. And there is a spacing at the end. To notice that spacing, I'll mention a word here. Let's run it now. And that is all about multi-line string lateral. Now let's talk about the fourth one, that is the Boolean lateral. And it's pretty simple. There are two laterals, that is true and false. And these are pretty much just the values. And now we can move on to the data types. So in this video, we have looked at Swift variables and let constant. And we looked at Swift laterals and its real world applications. In the next video, we'll talk about Swift data types. So let's connect in the next one.